Welcome back to math class. This is Mrs. Witt, and today we're going to be practicing factoring with rational coefficients. So let's begin by making sure we're all talking the same language. We're going to remember that if something is equivalent, it has the same value. And I know I'm really kind of beating this in your head with a lot of these, but it's very important that you remember what these terms mean. A variable represents an unknown value. The coefficient is the copilot to that variable, and it multiplies to the variable, multiplies the variable. You'll find it generally right in front of the variable. The constant is a number. Its value is constantly the same. We know that when we distribute, we multiply across grouping symbols. Most of the times we see that as parentheses. And that factoring, that's an operation we learned about in our last lesson. And that's basically how you undo you undo when you distribute. So if when we are distributing, we are multiplying, factoring, you're really dividing to find the factors. And what are factors? Well, factors are just what you multiply together to get your product. So if I said 2 times 3 equals 6. 6 is my product, and 2 times 3, those are my factors. So those are the terms that I multiply together to get that is my product. All right, so that's a quick review of all the things we've already talked about. And let's go ahead and start by, let's just engage our brain and kind of go with what we did last lesson. And I want you to find all the factors of the following numbers. You can use the list method like we practiced. All right, so I've listed out all the factors, and then I went through and read and found all the factors that are common. So that's going to take me down to this last step, and that is where it asks me the GCF of 4, 12, and 56. Well, I see that the biggest one this has is a 4, the biggest one this has is 4, and the biggest one this has is a 4. So I know that my greatest common factor is indeed 4. So let's just practice distributing really quickly too. If I look at this, I see that I've got a positive 2 times the expression x plus 7. So I want to distribute, which means multiply. So I've got these two factors, 2 and x plus 7. And I know that I can distribute the 2 to both of those, which would give me 2 times x plus 2 times 7. Okay. 2 times x is 2x. Positive 2 times positive 7 is 14. So what I've got is my final expression, my product here. So this is my product after I've distributed. So the factors of that product, 2x plus 14, we can easily see by looking back that my factors were 2 and x plus 7, because when I multiplied them together, I got that final product. So I want you to consider for a minute, if you're given the factors, you distribute to find the product. And if you're given the product, you can undo it to find the factors by using inverse operations. So if we're distributing, we factor. So to undo that, we would go back the other way. If we're factoring and we want to undo it, we could distribute. So think about distributing is essentially multiplication. The inverse of multiplication is division. So let's divide the greatest common factor out of the expression. So let's try with this expression right here. All right, remembering our inverse operation, distribute to factor, factor to distribute. I have this product, 3x plus 12. So I'm starting with the product and I need to factor it. Well, let's start by finding what the greatest common factor is. We already know how to find the GCF of 3 and 12. Let's divide them out to find out how that breaks up. But what do we do about the variable x? Because it's hanging out there. We don't know what to do with it yet. Well, let's think about this. So first, let's find the GCF of 3 and x. Or 3 and 12. Let's ignore the x first. I've got 3. I know. Let's see, I've got 1 and 3. Those are it. With 12, I've got 1, 2, 3, 4, 6, and 12. Those are all the things that go in there. And I can see right here, they both have 3. So I'm going to say that my GCF is 3. So to factor it out, I'm going to take this expression, 3x plus 12, and I'm going to divide out of each term, of each term in this product. I'm going to divide that GCF out. So if I divide 3 out of here and 3 out of here, because I have to do it to the same thing there, well, I'm going to list my 3 first, because that's what I'm taking out. That's the first factor. Then I'm going to start my parentheses. Well, 3x divided by 3 is just x. And a positive 12 divided by 3, well, that gives me a positive 4. So what I've done is I've created this equivalent expression that consists of 2 factors, right? I've got my 3, and I've got my x plus 4, and those are the factors of 3x plus 12. We can always check that by just redistributing. So if let me peek at this. 3 times x does give me 3x, and 3 times a positive 4 does give me plus 12. Those are equivalent statements written in different forms. This you might want to, this is your expression over here, but you could think of this as the factored form. Factored form of that expression. Now let's have you try it. I want you to start by distributing. All right, I've given you a minute to do that. And you can see the work here. I took my 11 times each of the terms, and I noticed that I ended up with plus a negative 33. So I can just write that. I can say that 22x minus 33. So the factors of 22x minus 33 are this thing right here, because when I multiplied them together, I got this product. So, and remember, this is just kind of a thought back to just kind of a side note. How can I go from this step to this step? Well, remember that when we subtract, this is just a side note on why we can write that as a minus. We know that subtracting is the same, remember back to the very beginning of the semester, as adding the inverse, right? So right here I had plus a negative 33. That's the adding that inverse of 33. So I could just rewrite that as minus 33, because subtracting is the same thing as adding the inverse, okay? Okay, so now we're going to practice kind of the undo, which is the factoring. So I'm going to find what is the GCF of 22 and 33. Well, I can use my list method. So I could say that, well, 22, let's see, 22 has 1 and 22, 2 and 11, 3, 4, 5, 6, 7, 8, 9, 10. No, that's it. 33, we've got 1 and 33, 2, 3, 3, and 11. We can see that the biggest one there is 11. So let's see, 1, 2, 11, 22, 1, 3, 11, 33. They both have that 11. So my GCF is 11. So that's what I want to divide out of both sides to find the factor. So I'm going to take my first term and divide by 11, and my second term and divide by 11. So 22x divided by 11. Well, I'm going to put my 11 out front. I'm going to start my parentheses. 22x divided by 11. Well, that just gives me 2, and my x didn't go anywhere, so I have to keep it there. And now I have my negative 33 divided by 11. Well, that's minus 3. So this is that undo. And let's look back. 11 times the expression 2x minus 3. Let's see, is that 11 times the expression 2x minus 3? Good, we did it. So that is, we successfully factored and distributed to see that we made equivalent statements. All right, now here's a time for you to try. You're going to find the GCF of 12x plus 30. You can use the list method. And then you're going to factor the expression by the GCF. So you're going to divide the GCF out of each term. All right, I started by listing my factors. I see that they both have a 1, a 2, and a 3. So let's see, they both have 1, they both have 2, they both have 3, 4, 5. This one has a 6 and this one has a 6. This one doesn't have a 12. So I see that my GCF is going to be 6. So now I want to factor the expression by the GCF 6. Okay, so I'm going to start with my expression 12x plus 30. And I'm going to take and I'm going to divide 6 out of both of them. Okay, so I'll start by writing my factors over here. I know that 6 is one of them because 6 is what I'm dividing by, and then I'm going to start my parentheses. Well, let's see. 12x divided by 6. Well, 12 divided by 6, those are both just numbers. So I can look at those and say, well, 12 divided by 6 is 2, but I didn't get rid of the x. The x is still there. And then, let's see, 30 divided by 6, and that turns into 5. So there we have it. This is the factored form of the original. So I can say that, let's see, I could say that 6 times 2x plus 5, that is equivalent to 12x plus 30. So let's recap. Distribute and factoring, those are both operations that are the inverse of each other. So those are inverse operations of each other, right? And essentially we know that when we distribute, what we're really doing is we're multiplying across those, across the parentheses. And when we factor, we're essentially reversing that and dividing out a common factor. And the GCF, what's significant about that is it is the greatest common factor. Greatest common factor. Now, could we distribute out something that wasn't the GCF? Could we just distribute out any old factor? Well, we could. We could distribute out any common factor to help manipulate it if we wanted to look at an expression in a different way. But you're not going to have the most simplified expression if you're not taking out the greatest common factor. Kind of like when you reduce a fraction and you see that it's even, so you divide it by 2, but then it's still even, so you can do it again, and you might have to do it several times to get to the simplest form. Well, that's what would happen if you factored by a common factor that wasn't the greatest. You would end up with an equivalent statement if you did it right, but it would not be the simplest form, or the factors that we are looking for in this lesson. So with that, you should have enough information to start working on your practice and choice board. Happy math. Get after it.